my people, Science Genie again. So now today we are dealing with haloalkanes. So your haloalkanes basically they are alkanes that have halogens replacing your hydrogens basically there. So your halogens are going to be having like so when every time in your general formula we have X, it's gonna be any one of these halogens, your bromine, your fluorine, your iodine, or your chlorine over there. So now, when we are having those guys, anytime we want to refer to bromine, we are gonna say bromo. Anytime we are going to fluorine, we say fluoro. Iodine, it's iodo. Chlorine, it's going to be chloro. And then these guys we are gonna refer to them mostly as your substituents because they are going to be substituted in space of your hydrogens over there. But then it's gonna be the same as your side chains. Your side chains are substituents, but then you can say that your halogens are going to be the substituents in most of the cases because the branches we call them side chains. So now anytime now we are going to having your bromine or your chlorine or your whatever in your molecule just like here, these guys they are gonna be on a certain carbon atom basically. So then as we have to tell where these guys are, we are going to indicate where these guys are like this. So you're gonna say 1 dash bromo. So if we say 1 dash bromo, it tells you that this bromine is on the first carbon. And then if we say 2 dash chloro, it tells you that we have a chlorine on the second carbon. If we say 5 dash fluoro, the fluorine is going to be on carbon number 5. So that's what's happening over here. Just like as you can see, this bromine is on carbon number 2. So we say 2 dash bromo, and then we say it is propane. And notice again that the suffix is going to be ane because these guys are still alkanes just with a halogen that is substituted there. So let us look at other types of molecules over here. So these other types of molecules, you can have your 2-fluoropentane. So now you can see that this fluorine is on carbon number 2, then it's 2-chloro pentane over there. And then if you see here, this guy is following the general formula CnH2n plus 1x. And then now if you check, if you put a 5 there and you put another 5, it's 2 times 5, which is 10 plus 1, which becomes 11. So you have 11 hydrogens, and then you have a fluorine over here. So now let's look at this type of case now where you have two different halogens. So in these molecules, we are going to have some cases where we have what? Two of the halogens or three or four of the halogens. So now it's gonna be that case whereby now you see we have a chlorine and a bromine. So now this says it's 2 dash bromo dash 3 dash chloro butane. So now with that being said, this molecule has four carbons, and then if you would count, we have 1, 2, 3, 4, 5, 6. So it becomes now 7, 8, right? So it becomes 8 hydrogens, and then we have a chlorine and bromine. So this would be the molecular formula of this guy. But now, when it comes to the general formula, this now becomes CnH2n X2, right? Like this. So now every extra guy, every extra halogen you are gonna add, right? It's gonna be substituted in space of a hydrogen. So then every time what we're going to do, let's say now you have three of your halogens. So if you have three halogens, let's say it's CnH2n, and then you have three halogens, so it's just going to be what? X3 over there, but here we are going to subtract one of your hydrogens over here. So that's basically how it's going to go. And then yeah, we have some molecules where we have these two guys repeating, and then we say it is 2,3 dash dibromo butane. So now that was just a glimpse of your haloalkanes. We have a lot more of these molecules. They're very fascinating. Let us go to the next videos where we explore the homologous series.